So this is how you approach acidity. First, you take away the proton to see how stable it is, and then the stability of a molecule is determined by four things: the resonance of the molecule, the atom, right? The atom, the negative charge is on, inductive effects, and the orbital effects. And this is one of the effects. Alkynes, right? Alkynes are more acidic than hydrogens on the nitrogen. So to test it out, try this problem and then I'll explain it. Okay, so to answer this problem, the first thing you need to do is take away the proton on each one of these, right? So you take away this proton, this proton, this proton. If you have a terminal alkyne, which just means that there's a hydrogen on the triple bond, and an alkyne is a triple bond, you just take away the hydrogen, and so there'll be a negative charge there, and then a hydrogen from the nitrogen. So just to show what that means, for example, you have the lone pair right here, and then you have the hydrogen. So just take that hydrogen, not the hydrogen, but the proton, right? The proton away. The lone pair will go down onto the sulfur atom, and then it will have a negative charge. So now we just label everything we know. So for this one, right, we take away the hydrogen, or the proton, I'm sorry. We take away the proton, and then we have a negative charge on the oxygen. So for this one, right, notice how there's a double bond right here. The double bond, or the negative charge, can go right here, form a double bond, and this this double bond can go up and form a negative charge. So this structure has resonance. For the other two, it's just based on the atom, right? Is the only difference between these two molecules is the atom. Over here, this is actually an orbital effect, where it's we take away a hydrogen on the alkyne and it becomes negative on the alkyne. And then for the final one, on the nitrogen, once again, it's just dependent on the atom. And so this list is actually in order of the most important to least important, right? So it goes 1, 2, 3, 4. So the most important is resonance. So resonance will beat all of these, right? Resonance beats atoms and orbital effects. So this one will be number 1. Now what do we look at? We look at atom, right? So we look at these three. Now before I start atoms, I have to mention that this alkynes are more acidic than hydrogens on nitrogen is actually an exception to the rule. So even though it's fourth place, right? It's fourth place, and so it should be the least important, making this immediately 5. It's actually not, because since it's an exception, it actually makes it better than nitrogen, right? So keeping that in mind, we can move forward. So we're looking at atoms, and for atoms, we look at electronegativity, right? Because electronegativity determines how much the atom wants the electron. And stability increases as you go right on a period, and stability increases as you go down on a group. So since these two are pretty far to the right, they'll be 2 and 3, and these two will be 4 and 5. We just have to look at which one will be 2 and which one will be 3. So stability increases as you go down on a group. So these two are in the same group. So as you go down, it's first oxygen, then as you go down, it's sulfur, right? So as the trend states, stability increases as you go down. So that means sulfur is actually more stable than oxygen. The negative charge is better on the sulfur, because since sulfur is bigger, right, because you're going down the group, you just added a ring of electrons, which makes it bigger, and it means that it can hold the electrons much more better than the smaller oxygen atom. So this one will be 2, this one will be 3. So right now it's 1, 2, 3. Now we just have to figure out these two. For the exception, right, alkynes are more acidic than hydrogens. That means that they're better at being an acid. That means that they're more stable. So if this one's more stable than nitrogen, that means that this has to be 4 and this has to be 5. So this is the answer key. So it's 1, 2, 3, 4, 5, right? Because 1, because it's resonance beats everything. 2, because as you go down a group, it's more stable. then 3, just because oxygen is to the right, and that instability increases as you go to the right of a period. And then for these two, this is the exception where alkynes are more acidic than a nitrogen, and so that'll be 4, and then finally this will be 5. So I hope that helped, and thanks for watching.